Welcome back. We are continuing our talk on agents. So the basics of agent behavior having understood, we want to be able to develop an agent. That's the basic job of artificial intelligence, is to design an agent program that implements the agent function. That is the mapping from the percepts to the actions. So let's assume this, that the program will run on some sort of computing device. That is the device will have certain sensors for sensing the input and actuators for the actions. So that is called an architecture. And this so putting it in another way, an agent is equal to an architecture plus a program. So the architecture is the one that will be running the kind of program. So what it means is the kind of program which we put on that particular agent should be appropriate on the architecture which we have in place to run the program. For example, if we want to have an agent that is going to be able to percept, it means the architecture should make the percepts from the sensors available to the program. It should run the program and feed the program's action and choices to the actuators as they are generated. If you want a program that can give actions like movement or from place A to B, it means that the architecture should have actuators that can enable an agent to move. So basically, the program that is designed has to be appropriate to the kind of particular architecture. So this agent program, most of them, they follow a particular skeleton. That is, they take the current percept as input from the sensors. It takes what the sensors will send from the environment and gives to what to the architecture. Then it retains the action to the actuators. So basically, that's the skeleton, whereby a percept and retain an action. So there's a difference which we ought to note there also, which comes between the agent program and the agent function. So the difference is like the agent program takes the current percept as input, right? That is that current percept only, whereas the agent function now take the entire percept history. For example, if certain behavior requires many percept sequences, it means that the agent will have to be persistent in some way that it can look up and take note of quite a number of percepts until it come up with a certain behavior. So the agent function is the one that will be invoked there when there is a series of percepts that needs to be accomplished in order to achieve certain behavior. So the procedure now to construct one particular agent, what the designer should do if they want to construct a rational agent. Note that this is instructional. It's a way to learn, although it's very difficult to construct such a table. But the instructional method or way is that to construct a rational agent, the designer will need to construct a table that contains the appropriate action for every possible percept sequence. For our previous example, which we gave before, that of that robot that does the cleaning, a table will be developed like this one, which we can see, whereby we can list the percept sequence against the action that needs to be taken. So it is the designer, you, the one who will be designing the agent, we need to come up with this kind of table. That if, for example, if square A is clean, then move to the right. If square A is dirty, sack. If square B is clean, move to the left. If B is dirty, sack. If A is clean and A is clean, the table is like you are putting every possible percept sequences. But like what I said is that this approach now, it's instructional. It's for, since we are beginners to artificial intelligence, it's a way to understand like how to put it. So basically, after coming up with this table, the designer would then move to come up with a particular agent program. So here is a simple example of an agent program that keeps track of the percept sequence and then uses it to index a table of actions to decide what to do. So basically, the skeleton is we have highlighted before. The selection, the skeleton is like it inputs the function takes in a percept from the particular sensors and returns an action. So this is the function prototype. For example, function table driven takes in the percept and returns an action. So that's the signature of the function, and the inside of the function, for example, if the behavior is going to require a number of percepts so the function now will be end of percept sequence, which might be initially empty, and from looking to the table, there will be a table of actions being indexed by the percept sequences, and the table is initially fully specified by the designer. It's like the previous table in the previous slide. So the actions within the function, you append the percepts to the end of the percepts, and the action you look up from that percept table which we talked about. So this is a simple skeleton which simply explain that you can see here that at the end of the function it will return what? The action. So that table is showing us a table driven agent program that is invoked for each and every new percept and returns an action each time it retains the complete percept sequence in the memory. So that's it for now, but as I've said, that's instructional, and we need to look at more ways that are feasible to develop this agents program.